So now we are in lesson 9.5. It's about the vector product and the properties. We did already in the preceding lesson the dot product or the scalar product. Now we're going to do the vector product. First, you need to know what is the notation of the vector product. So it's like times, it's like an x. So this is the notation of a vector b. In some books, you can see it like this. Also, it's represent the vector product. So what does it mean, the vector product? From the name, when I say the vector product, it means the product of those two vectors will be another vector. So the vector product of two vectors is a vector, and this vector has a special position. We saw in the preceding lesson that the dot product gives me a number. The vector product will not give me a number, it will give me another vector. So, and this vector is perpendicular to the other two vectors. And it's not just any position of perpendicular. Those three vectors, they need to follow the right hand screw rule. So if I say A vector B is equal to C, so if this is a vector A and this is a vector B, I'm going all the time counterclockwise. So the vector C will be a vector perpendicular to the two vectors A and B and in the positive direction. So I have a formula using the angle. As you saw also in the preceding lesson, you have a formula. You have two formulas for the dot product, one algebraic one using the coordinates and one using the angle. Also, I have here the same thing. I have two different formulas. So, but it's not A vector B. It's, we say magnitude of A vector B. It's equal magnitude of A times magnitude of B times sine theta. And what represents theta? Theta is the angle between the two vectors A and B. And also we can see it this way. You can write it this way. A vector B is equal magnitude of B times magnitude of B times sine theta times n. What represents this vector n? N is a unit vector whose direction is given by the right hand screw rule, as I said before. What is the geometrical interpretation of the magnitude of A vector B? The magnitude of A vector B is gonna be the area of the parallelogram enclosed by A and B. Because if I have those two vectors A and B, if I do a parallel vector from here and from here, I will have a parallelogram. So to find the area of a parallelogram, it's enough to do the magnitude of A vector B. And you know that half of the parallelogram will be a triangle. So how are we going to find the area of the triangle? It's half magnitude of A vector B. Now we will do the example of the algebraic vector product of two vectors. So if I have the vector A 2, 3 minus 1 and B 4 minus 1, 1, this vector I can write it as 2i plus 3j minus k, and the other one is 4i minus j plus k. To do the vector product of A vector B, first you put the vectors, the unit vectors A, J, K. In the first line, I put the vector A, it's 2. The coordinates of the vector A, it's 2, 3, minus 1. And in the second line, I will put the coordinates of the second vector, 4, minus 1, 1. And then the answer will be, you will write I minus J plus K. Now, how are we going to find here this number here? So now we need to find the coordinate of I. So as I'm canceling this line, so I just focus here. I look in and I do 3 times 1, it's 3. Minus 1 times minus 1, it's 1. And then the second one, minus j. So I will ignore this line. I will do 2 times 1, it's 2. Minus 4 times minus 1, minus 4. And then the last one, k, I will ignore this line. I will do 2 times minus 1. It's minus 2 minus 4 times 3, 12. So it's minus 12. And then I will just do the operation. 3 minus 1, it's 2i. Minus 2, minus 4, 2 plus 4, it's 6. And then I have a minus here, so it's minus 6j. And then I have minus 14k. So what does it mean? It means the coordinate of the vector, that a vector product of A vector B is 2 minus 6 minus 14. But this vector also has another nomination. This one we call it's the normal vector of the plane formed by the vector A and B. We have some properties here. A vector B, it's not the same as in the dot product. A dot B is equal B dot A, but in the vector product, no, because you know that if A is like this and B have the same direction, for example here, the angle here is 0, but when I have different signs, it's going to be the angle minus 180. So it's not the same thing. So A vector B, it's minus B vector A vector B vector C, it's the same as A vector B vector C. Lambda, so if lambda belongs to R, if it's a real number, as I have a distributing property for the numbers, and if I have A plus B vector C, it's A vector B plus B vector C. Now let's move to another formula here. We call the mixed product. Mixed product, it's a mix between the vector and the dot product. In this case, the answer is a number. It's not a vector because this one is a vector, dot another vector, so it's going to give me a number. So let's say I have the same vector A and B. I have a new vector C2, 4, 3. If I want to find A vector B dot C, first A vector B, this answer I have from the preceding part, it's 2 minus 6 minus 14. And then I do the dot product for those two vectors. It's x prime plus y prime plus z prime, and then I will answer minus 62. And now, how can I do the geometrical interpretation of this mixed product? If A vector B dot C is equal to 0, it means A, B, and C are coplanar. What does mean coplanar? It means they are in the same plane. So they form a plane. So if they form a plane, so they are in the same plane, so they can be like this in the same plane. But if A vector B dot C, so sometimes I can ask you, show that they are coplanar. So it's enough just to do the mixed product. If it's 0, it means they are coplanar. If it's not 0, it means they are not coplanar. What does mean they are not coplanar? It means they form a 3D shape, not from. So they form a 3D shape. So when they form a 3D shape, so I have a geometrical form. So in this case here, if for example we do the parallel here, then I do a parallel here, I do a parallel, a parallel, a parallel. I'm gonna have in the end, if you look at it, it's a parallelepiped. So it means the mixed product will help me to find the volume because I have a 3D shape. So I'm talking about a volume of the parallelepiped. So what's gonna be the volume of the parallelepiped? So it's equal absolute value of the mixed product of A vector B dot C. So in this case, I already did it here. The answer was minus 62. So what is the volume of this parallelepiped? It's 62 unit cube. But sometimes you're going to tell me, Miss, sometimes the three vectors can form a pyramid, a triangle pyramid, base triangle. It's not a parallelepiped, yes. So if the three vectors form a triangular pyramid, so here in this case, the volume of this pyramid, the triangular pyramid, will be 1 over 6 magnitude of A vector B dot C. Let's do an example for that. Find the volume of a triangle pyramid with vertices A, B, C, and D. So first of all, I need to see those vectors, the coordinate of those vectors. So let's find the coordinate of those vectors. So you know the formulas, how to find the coordinate AB, it's x of B minus x of A. So those are the coordinate of the vectors. And then to find the volume, I need to do 1 over 6 magnitude of AB vector AC dot A D here. So I will do the AB vector AC first. So AB vector AC will give me this answer, so I know how to do it. And then I do the dot product between AB vector AC and AD, and the answer is 51. So what's going to be the volume of this triangular pyramid? It's going to be 51 over 6. It means 17 over 2 unit cubed. That's it for this lesson. We'll do more application in the class.